Okay. I took this from Scientific American, and it just shows there's one word in there, retreat. And that seems to be a very common theme for many of the district councils or people here. And what I wanted, the topic tonight was, it's not necessarily retreat, and the way I see that developing in New Zealand, it's not a retreat in good military order, taking the wounded and dead with you. It's more like piss off and leave everybody to it. And I don't think that, I think there is a big alternative to that. One of the things is just when I'm talking about coastal hazard, the big one is climate change and sea level rise. But there are also hazards that come straight from coastal erosion, and that is where, when you look at Otago, for example, with all the hydro schemes on the big rivers, the amount of sediment coming to the coast has decreased, and coastal erosion occurs all along the Otago coastline. But the big one that's coming is sea level rise with it. And how bad will that get? Well, when you look at the IPCC recommendations on it, and these are the representatives concentration pathways, the worst case, if we look at the median, that puts it at about 0.8 by 2100. If we look at it where we're able to get it under control, we're back to about half that. But the planning in New Zealand at the moment is on that 0.8. But that is 2100. And what you've got to look at is the normal sort of design life of engineering structures is about 50 years. And I've been about long enough to see that actually happen. In terms of Lyttleton Port Company, I was involved in the design of the first container wharf, and it makes you feel how old you are when that was actually demolished. There was nothing wrong with it. They put a new one in. So when we're looking at engineering structures, because I hear this thing several times, and you see it in magazines like The Listener, that seawalls or structures don't last, they'll be gone. But in normal engineering design, it's about 50 years for structures. Except when you look at the outfalls, for example, they all use or the latest ones use polyethylene pipe, and that'll last, when it's not exposed to the sun, that would last for 100 years. So we'd have to look at something for 100 years. But if I look at it, this is the Omarou Breakwater, and it was built in 1880. It's still working. I don't know how it was built in the first case, mainly because this is the sort of conditions that occur regularly when you get it. It's still there, it needs maintenance. But when I look at that as a seawall, that is now 140 years and it's still going, and it's actually vital. Just when we look at types of coastal hazard mitigation, structural changes to the natural environment, that's armouring or hardening, beach stabilization, I'll explain these as we go through. Then you have the non-structural changes, and quite a bit of that is retreat, move structures, zoning, land use restriction. And the other one is like a do nothing, just leave it, and a phrase I hear quite often is let nature take its course. If I look first at the armouring, typical ones are like this, the rock armour slope, and it depends a bit on what the wave environment is. You can also have articulated concrete mattresses. These are little blocks that are joined by ropes. You can have something like this, a precast unit where the wave breaks over it, carries sand up, but holds it on that side. Or you can have a concrete structure. These are typically at the bottom of a cliff that's eroding, and that reflects the waves. Or you can do something like this that I'll look at. This is an existing retaining wall, and we put a slab on it. this is some. I'll show you one at Nelson. This is a normal design of a rock wall. So you have the rock like that. It's all closely sized. You have a filter layer under it with geotextile cloth. This one was proposed for Pakawal in Golden Bay. This is a serious rock wall at Omarou, and that one was put there in 2007 when they had a series of huge storms like this that just destroyed the ad hoc rock wall they had. Initially, there were rocks just thrown over the edge by the New Zealand Kiwi rail yard. There were rocks just thrown over the edge, and there were locomotives as well. Any old rock they find, they threw it over. Then they had a big storm like this that just utterly stripped everything off it, and we had to come back and put those rocks on there. That was like an emergency one, because if it hadn't been done, the railway yards would have disappeared. That was sort of typical of the damage. The rocks just totally, that were there, totally disappeared, and there were huge chasms like this that came back right into the rail yard, threatening the destruction of the whole thing. So that was sort of like an emergency response to it. And one of the things about rock walls that's often held against them is they destroy the beach in front of them, and that's what happened there. There's no beach in front of this one. There is a beach at low tide, but it's a feature of them. The waves reflect off it and remove the sand from it. So they're not necessarily an attractive structure on it. This is south, where I showed you is up there. That's now all armoured. But just further down near the penguin colony, this is the sort of thing that happens. Occasionally they have a storm. It just rips into the bank and goes backwards. Now what was done there was another rock wall like that. This one is back from the normal beach level, so the sand actually stays in front. But what we looked to do there was actually put an offshore breakwater in, and that would help build that up. But again, that was a cost situation for the Waitaki District Council. They didn't do that one.
Is that rock wall something similar to Summers, or is that more substantial?
Sorry,
that rock wall in the previous slide that you've just shown, is that
Yep.
what we have at Sumner? Sort of?
Yeah, same sort of thing, except the one in Sumner is right on. There is no beach at sort of low tide with it. It's closer than this one is. This one's sort of further back at the top of the beach. So when sea level rises, it will get like Sumner. You will lose that beach in front. But there's nobody sort of really swimming on that one anyway. This is another one at Hastings. And in this case, it's just the rock is put in to protect. This is an outfall location. So it protects the outfall. So what will happen in time with that is this whole area will go back and we'll have like a little peninsula with the rocks on it. That's sort of just to protect a specific piece of infrastructure. This one is another way is to put a wall there, and this is Sinclair in Dunedin. This has been a bit of a disaster. See the rocks sort of along the bottom because these are concrete like sheet piles that go down, but they weren't down far enough. They got eroded. There were big problems with it. But the problem they have here is the commercial buildings, everything is right up there. They have to be there or pull everything back. And this one, there's not much sand stays in front because again, you get a hell of a lot of reflection straight off that wall. So that is not a very nice solution. You can see there used to be stairways down there. They got wiped in big seas. So it's a difficult one to do, but you can design that. This is sort of a design problem. You could do better than that. Oh, hang on. What you can do if you don't have big enough rocks, is actually use precast concrete armour units. And there's a whole stack of them, huge things like this. So it means you could put those out in open sea conditions. It's very expensive. It gets more expensive the way you do it with the depth. But you can stop wave action if you want to, and you have the budget to do it. I think a lot of this is actually cost benefit. Is it worthwhile to actually give the protection? And what are you actually protecting? Does it justify putting that in? That just shows, these ones are also at Omarou, the only place in New Zealand that has sort of big moulds. Historically, they had those moulds. Each one of these is 15 tonne, and it cost about $2,000 to make each one.
When did they put those in Omarou?
Sorry?
When did they use those moulds in Omarou?
They first came there in the 50s because they don't have good rock in that area. And when we did a repair on part of it, we used them because they had that mould. So that was about 2007 when that was done. One way to put a wall on is this. This is actually for an offshore base or a quay, but you can use that just to keep the sea up and just fill in behind it. This turns into a supply boat base. This is sorry?
Just sheet piling.
Steel sheet piling.
Yeah.
Yes. That you don't use those really. It's a bit like that sort of Dunedin case. You normally wouldn't use them in a high energy wave environment because you get so much reflection. But it's a very tough way. In this case, it's used as a quay, and this is in Papua New Guinea. When I took that photo, I didn't know what the hell was happening to this. It was a boat on a list. He didn't actually hit anything. But Now, the other way of doing it with hard, this is one at Tahanui that we did. This is the Rocks Road seawall. And what was happening at the end of the beach is that they were losing sand. And the water of the sea was breaking through into the playground and the park behind it. And we were asked to look at it and see, okay, can you fix it? What is the problem with it? And there were two problems. One, that wall, the original one, is close to vertical, so the waves reflect straight off it. And when they reflect off it and hit the beach, so the wave comes in, it disturbs the beach, then it goes back out, a perfect reflection. So it disturbs the beach twice, the sand can't stay there and disappears. So they lost the sand, they were breaking through into the car park behind it. And the other thing was they had a huge drain that discharged straight on the beach, keep it permanently saturated. So the idea here was to reduce this reflection and put a drain under there. Now, at the time, the Nelson City Council was really divided on this, and it was like split down the middle. There were a group of Green councillors, just in terms of political affiliation, not someone that had been there a long time. But they opposed any form of hard structure. And there were even bits in the paper about aggressive rocks, and nobody wanted this. But this has actually worked really well. Does it cut the reflection? This is the case. See the problem? This whole end of the beach can be usable. It's dry at high tide. Another thing is, you see the stairway going down has disappeared into the sand. The whole thing has built up, and all the noise about it being hard protection has disappeared. So I think if you actually design the thing just to cut down reflection, and in this case, all the drained water runs out to sea under this.
So does the sea go?
The other one, when you talk about stabilization of the beaches, there's a number of ways to do it. You can put in offshore breakwaters like that, and what they do is dissipate the wave action. They don't have to be sticking out of the water. They can be under the water, they just cause waves to break, and it's easier for the sand to accumulate inside, and it builds out like this normally behind the shelter. Depending on how far these are offshore and the gap, you can actually have the sand come out and come in behind the breakwater. And this is something, I think if that was done at Sumner, for example, you'd get the beach back. There's plenty of sand there, you could do something like that. Yeah, they're a bit, the surf reefs have been tried on some of those. I don't know of one that's currently operating. And I think that's partly a construction problem rather than a theoretical problem of how you do it.
So in places like the Gold Coast and Sunshine Coast, where they've done these sort of things, it's sort of just moved where the sand gets moved from?
Yes.
Is that, so do you just move the problem to somewhere else, or?
It can do.
Right.
If you're doing something like this, groins sticking out from shore,
Yeah.
they capture the sand, and on the downside of it, so that assumes the sand's going this way.
Yeah.
On the downside of that, you do get some erosion, then it builds up again. So that is sort of robbing it from further down the coast with it. Yes. This one is an expensive option to actually build that sort of thing out there. A groin isn't that expensive to do. It's quite easy to do it because you're not, when you're at the shoreline like that, it's not the same as being out in the surf zone. So something like that is right in the surf zone. One way, I haven't seen, they've been used in Japan, but this is quite an attractive way of doing it. These are like precast units that you could float out and put in position, and the waves are forced to break over the top of it. One of the things I like about them is the force goes through the centre of it, so there's not actually any overturning force that happens on it. That is a sort of smart way to cut the wave energy before it gets to the shore and starts causing problems.
How much below the surface would you do those?
It depends. If it's big swells, something like that, you don't have to be, you can be quite far, below. It's
And
just,
it still has the impact?
yeah, it depends on the wave period. For like a easterly chop, you've actually got to be up stopping it because the energy is concentrated in the top. With a big swell, it's from the surface right down to the bottom. So you need to intercept quite a lot of it. This is just, say, examples of this. These are the little offshore breakwaters, and see, they actually come out like this. If any of you go to Singapore or have been there, they have some of these all along these coasts. It's quite an attractive way of doing it. And that shows ones that are actually emergent. They're sticking out of the water from that. But what happens is that you can build up the beach, behind them to get quite an attractive feature. This is High Moana along from Hastings. And this one, when you look at it, what to do about this, you wouldn't try and do, well, you could put a rock armour wall along here, but it'd be a big one and it'd be ugly. This is sort of like a solution where you would put a submerged breakwater out here and completely cut the energy that's smashing into these. But again, there's only a few houses along here, so it'd be very hard to justify the expense of doing that. There's another one, same sort of thing. I think an offshore breakwater would work good in that, and particularly if you've got high density of housing, you're covering protecting a big area so that you stop the really big waves smashing into this and allow sand to accumulate. That's much more attractive than you see down there, the sort of like makings of a rock wall to actually do that. Now, one of the problems is the New Zealand Coastal Plan, and say that in there, the policies they have, it's this one, discourage hard protection structures and promote alternatives, including natural defences. that has been quite a sticking point for resource consent applications. And I think of, well, if I just go to this one first, this is Pakawar. And just last year there was a resource consent application that we were helping on. At Pakawar, they're trapped between the road and the beach. And the camping ground has a rock wall in front of it that works. Now, all these residents along here, these are all people in their 70s, and they can see that the beach is disappearing. It's getting closer and closer to here. So you have a big southeasterly event, and they lose a lot more sand. Now, what the council has been doing, and they're particularly in the Tasman District Council, they're focusing on natural solutions. They don't like hard ones. So what they do is get a bulldozer out and push sand up against this. It's called a push-up. I think I might as well do press-ups on the beach for just the use that they're actually doing, because the first storm, the whole lot's gone. Now, what the residents wanted to do was pay for their own seawall. The council wouldn't. So all these residents, and they're all over 70s, including the lady that founded the wearable arts one, they all agreed, okay, we want a rock seawall is the only thing that will stop it. And I think you can design something that stays there. And I think in the case of these people, particularly this, because if they're going to pay for it themselves, and this was a targeted rate, and they don't cause a problem to anybody else, I don't see why they can't. And in this case, it's total hypocrisy on the part of the Tasman District Council, because anything they need to protect, they put rocks around it. But for these people, they say, oh no, you've got to have a sand push-up. And when they went for the consent for the rock seawall, it was actually turned down. And there were some really, well, sort of emotional stories from the people that have lived there, you know, for all their lives. And I remember one lady that was a nurse, she's still working, well in her 70s. And she said, this is my sole capital asset, and it's going to be gone. I won't be able to sell it. I can't do anything. I want to protect it. And I think a lot of that is going to happen in New Zealand. And one of the things in turning it down was that coastal planning document saying that they don't like hard engineering or structures, and you have to go to natural alternatives. I think what's happened on South Shore is a bit of a turnaround from it. It's a promising start. But I also think that there's like an agenda in there that, a bit like sort of Trump, that the people on the beach are losers and they shouldn't have been there. They're all going to run away and leave them to it, which it's just when it gets called management retreat, I find that a really shabby thing. And I think it has to be addressed properly. And for me, if there's a cost-benefit analysis, you're protecting enough houses and you can protect it, then I think you should. It's not as if you're going to do it. You know, for, say if we look at 300-400 years, the sea might be 8 metres somewhere. But I think you have to look at design life of engineering structures, and you have to look at people's own lives as well. Some of that just seems to be, there's a fatalism, and I think they're looking too far out. And it's a fatalism that when you look at the Netherlands, for example, they don't have the option of this. I think it's something like 33% of the country is below mean sea level. And where would they go? They can't go anywhere else. And I look at somewhere I'm quite familiar with, at Singapore. What do they do? You just, and I see those countries, particularly like in Netherlands, are actively planning, you know, to make sure this doesn't happen to them. Whereas here, it just seems to be sort of abject fail, or just run away from the problem. And certainly in places, if there's not, and I think I'll show one picture there, again from the Otago place, where it's not worthwhile protecting the road because there is an alternative, further inland. So that's fine. But when they asked me about the sort of the council, the Otago Regional Council, I had to ask them once, their policy on these hard defences, this sort of thing. And particularly again at Omarou, the sewage works, it's not particularly old. It's north of the town, and the coast is creeping towards them. Same as Waitaki Boys hide these ones. And that's when I said to the council, would you accept armouring, around the sewage works? And the answer was yes, because it's like worth 80 million. It's a structural asset with it, and you can protect it. Now, with a proper design, you could do it. There was one question that was asked about this. The commissioner asked me, said, what happens if the sea came up and, over the rocks? What would be left? And I said, well, you're not going to get rid of the rocks. They're going to stay there. It would be like a reef. And the good thing about them, you can actually build on top of them. They're flexible. You could take it up. But she asked me what would happen if they did have their own seawall. And I said, this is wind up as a peninsula. The coast that go back either side. And typically when that happens, the sea action concentrates on your coast, on the the headland or your peninsula. It's just the wave refraction bends in on that, and the beach either side is protected from something like that. This one is just that. This is the road south of Omarou, and erosion's really been eating into it. But there's another road a few hundred metres back that way. So I think this one is the right sort of solution to it, because it was about 3,000 a metre to put rock protection all the way down there. So it was just too much money.
When was that taken, Gary?
Sorry,
When was that one taken?
that was after that. These things are sort of like episodic events. And in 2007, there was a really, they look at it, you say, okay, the coast goes back 1 metre a year, something like that. It doesn't. That's just the average. You have an event like occurred in 2007, and it goes 10, 12 in one event. Yeah. I just put this one in. This is sort of an example of what you can do. This one is the king salmon outfall from their hatchery at Tentburn, just north of the Rakaia. And they've never found anything that would actually stay there, because it's like being sandblasted. It's right in the surf zone when it gets rough, and the shingle gets entrained in breaking waves, and that's what happened. Any concrete or steel structure just gets smashed or gone. And the only one that's actually stayed there is that, where we have polyethylene. That's the same pipe material, and that's amazing stuff. It's just the rocks bounce off it without causing any damage. Now that's something, I just put that as an example of what you can do, even in the roughest environments. And part of my background is offshore oil and gas, so I've been on platforms in the North Sea. There are engineering solutions to do these things. It's just, and when I see the Department of Conservation or something like that, they're not big on engineering, and it's a matter of the cost of this thing. Is it worth doing it? But effectively, there's nothing you couldn't do to fix that. And the other one is adaptation. How you adapt to rising sea levels. And I'm a fan of floating houses. And in this area, where you look at this big red zone, I think it's a perfect solution, that you could have something like that and put all this land that's just totally useless at the moment back into service doing this. It's just this sort of thing is expanding overseas. It's just one that we looked at, that what you could do is you build your own little pond that you float in, so you get some protection, and that you, what you take out of the pond, you put a berm behind you. And funny enough, Regenerate bought out Dr. Christine Hill. She's at the University of Berkeley, that's been promoting exactly this sort of adaptation to rising sea levels around the place. I don't know why they did it in a way. They didn't take any notice of it. And anybody trying. Yeah, the only problem is, say tomorrow I'm going to Auckland to sign off a floating house structure there that's starting. The guy behind that came down here, spoke to Regenerate about doing something here. Could he have some land to lease it? They would give him a 2-year lease. It just...
We're just not up to that yet. We don't own the land, that's the problem.
Yeah, but it's just the sort of the attitude with it. It's the same. I actually approached Regenerate and said, just give us some land. We will build one as a demonstration. I think there's a lot of scope for adaptation, either using this or putting houses on piles. It just hasn't even started here and hasn't even thought of. And that for me is one way of doing the coastal hazard. There is one, I must have passed it. I doubt if that went, yeah. Another one, just in the case of Sumner, we looked at a Mariner Properties here. They had to have a coastal engineer to say about the foundations of the house, because you're assuming that Sumner gets inundated. So the council set the floor level for this. And then they had to have someone to certify, you know, that just with the currents that went past, with the scouring and everything that was going to go on around it, that you could get past this. And it was sort of like one of the questions, why would you do that? If you, say you look at, in the case of big surges or rising sea level and storms, you get all along here, you've got the seawall, you've got a concrete wall behind it. That's going to keep the sea out. This area isn't. And the whole of Sumner is going to be swamped with this. And when you say, I think we're just fiddling around here, looking at what about the foundation of the house with all this water that's rushing past it, I just struggled with. I said, surely you would put a berm from there to there. You know, just in terms of the capital value of everything stuck in behind it, it's easy to get past it. But at the moment, there doesn't seem to be, you know, in the council thinking. I said, oh no, we can't allow for a future berm. And so I said, well, we're worrying if this house here is going to be all right, but what about all the whole lot there, you know, that are swamped? I think that's what at South Shore we got the start of a berm, because for me that's another no-brainer, in that the threat in that case is not from the seaside, it's from the estuary itself. And it's not big wave action, it's not that hard to keep the water out of the place and buy yourself time, with it. And this is, when I see this one, there is one positive development. They're trying to build those sand dunes up, but there's a hell of a lot of work to do that. And I just thought that one of the things you would want to do is to mitigate the coastal hazard here by just being ready to build that up. The problem with that fend for yourself, they don't let you, to the sense that you can't protect yourself, and I find that wrong.